Hello everyone, today we will learn about the implementation of stack using array and link. The agenda which we will be following in this video is the basic idea of what a stack is, and then we will move on to representation of stack using array, and then we will discuss about the representation of stack using linked list, and finally the applications of stack. So what is a stack? A stack is a linear data structure which follows a particular order in which the operations are being performed. The order is LIFO, which stands for last in first out, or FILO, which stands for first in last out. So what is LIFO? LIFO is a strategy which states that the element that is inserted last will come out first. Now, let's say we have a stack of books here and you want to remove a book from the stack of books. Which book will you be removing first? The book which you kept last into the stack, right? Obviously the top one of the stack. That will be removed first. So the book which is inserted last will come out first. So this is how LIFO works. And that is the strategy of a stack. So let's move on to the basic operations on stack. Push is a function to insert an element into the stack. Pop is a function to remove an element from the stack. Top is a function which returns the top element of the stack. Is empty returns true if stack is empty, else false. Is full returns true if stack is full, else false. So let's see how these work. Push has two cases. Case 1 says that if the stack is full, then it is said to be an overflow function. So let's say we have a stack of size 5 and we are trying to insert a sixth element which is not possible. Then it says it's an overflow condition. Case 2 says that if the stack is not full, then adds an element. So let's say we have an empty stack here and we are trying to push an element which is 5. So that will be the start and the top of the stack as of now. And now let's try to push 3 into the stack, now which makes it the second element of the stack and also the top element. So this is how push function works. Now let's move on to pop. So pop also has two cases. Case 1 says that if the stack is empty, then it is said to be an underflow function. So let's say the stack is empty and it has no elements. That means that we just can't remove the element. So that is an underflow function, and if the stack is not empty, then it removes the top element. So let's say we want to pop and the top element is being removed here, which is 3, and now we have only one element in the stack, which is 5. uh, Now the top function returns the top element of the stack. As of now in this stack, 5 is the first and the top element of the stack. So the top function returns the top element, which is 5. Now let's try to see what is empty is. So is empty returns true if the stack is empty, else false. Now in this case we still have one element left in the stack, which is 5. So is empty returns false. Now let's try to pop the element from the stack. Now the stack is empty. So is empty function returns true. Let's move on to the next function, which is full, returns true if the stack is full, else false. In this case, stack is empty, so it returns false. So now we saw all the basic operations on stack. Now let's see how to use these on an array. In this method, an array is used to represent a stack. The variables used here are stack, which is the name of the array, and top, storing the index of the latest element added to the array named stack, max, defining the size of the array, which is named as stack. So top is a variable which stores the index of the actual element when it is pushed into the stack. As of now, top is -1 as we don't have any elements in the stack. Now let's try to push an element into a stack. So the algorithm of the push function is if stack is full, then it will return, then end if statement, else increment top. So when we actually push the element, the top will be incremented by 1 and it will assign the value to stack of top, which is stack of 0 as of now for the first element, and then we will end the else statement and end of procedure. So let's see how that works. So now we are trying to push 3. Now we incremented the top from -1 to 0, and we assigned the value of 3 to stack of top, which is stack of 0. I hope you got it. Now let's try to push 5 into the stack. Now the top is incremented from 0 to 1 and 5 is assigned at stack of top, which is stack of 1, the second element of the array. Now let's try to push 8. In the same way, the top is incremented again from 1 to 2 and the value of 8 is assigned at stack of 2, which is third element. Now let's see how pop works. The algorithm says that if stack is empty, it will return end of if, else store value of stack of top and then decrement top, end of else, end of procedure. Now let's see. The element which was inserted last in the stack is 8. Now the top is decremented from 2 to 1, right? Now the top will become 1 and the element which is at stack of top, which is stack of 2, the third element is removed from the stack, which is 8. So that's how it works. Hope you understood pop function. Now let's see how top works. Top basically returns the stack of top, which is stack of 1 here, which is the top element of the stack which is inserted last. So here in this example, this function returns 5. Now is empty. Algorithm says that if top is less than 0, it will return 2, else returns false. And procedure. Now let's say the top is equal to 0, that means the stack still has one element left. So if top is equals to -1, that means top is less than 0, then it means that the stack is actually empty. Here in this case top is equal to 1, which is not less than 0, so it returns false. In the same way, isFull function returns true if top is equals to size of stack, else it will return false. Here in this case, top is equals to 1 as of now. That means top is not equal to the size of stack, which is 5, so it will return false. So let's say we are trying to insert a sixth element, which is top equals to 5, then it will return true, which means the stack is full and we can't add any more elements. Now let's see how display function works. The algorithm of display function says that if top is greater or equal to 0, then for loop of I from top to 0 with a decrement of 1 will print stack of I. End of for loop, end of if statement, and end of procedure. Here top is equals to 1. Now for loop of I from top to 0, which is it starts with top and it goes back. Here now I is equals to top, so it prints stack of I, which is stack of 1, which is 5, and then it goes into the loop again with a decrement of 1. So now the top will be 0 and then it will print stack of 0. So the final printing in the interface will be 5 and 3. And this is how the display function works. So these are all the operations we can perform on stack. Now let's move on to the next topic, stack using linked list. So a linked list is a data structure made of one or more than one nodes. Each node contains a value and a pointer to the previous or next node, forming a chain-like structure. These nodes are stored randomly in the system's memory, which improves its space complexity compared to the array. So this basically says that linked list uses dynamic memory allocation. So a chain of nodes is called as a linked list. As you can see, these are all nodes and these are connected like a chain here. So what is a node? Nodes are a basic data structure which contain data and one or more links to the other nodes. Let's say we have a node here and each node has a unique address. In this case, let's say this node has an address of 2400. And then we have a data and a pointer which stores the address of the next node in each node. In this node, let's say we have a data of 12 and the pointer says null as it is not connected to any other linked node yet. Let's make a similar node with a data of 24, pointer null and address 2600. Now let's try to connect these two. If we try to connect these two, the address of the second node, which is 2600, will be stored in the pointer of the first node, which was null before, and the pointer called head is introduced here, which stores the address of the first node 2400. So this is where the linked list starts, and this is how it works. Now let's see how stack works using linked list. In this method, a dynamic data structure linked list is used to represent a stack. This representation leads to dynamic stack, that is, we use this when we don't know the definite size of the stack. Pointer or links is used to store the addresses of the nodes, which we just learned, and the variables used are top, holding the address of the topmost element of the linked list, just like how we did in stack using array. Now let's see the basic operations using linked list. The algorithm of push function says that new node data will be assigned by the value which is given by the user. New node next will be given the value of the top, which is a pointer we take at the start of the program as 0 at start, and then the top will be assigned by the address of the new node. End of procedure. So let's try to push a node with the value of 11 and the address of 4600. Now new node of data is value of 11, new node of next is equals to top. So now that the top is 0, the pointer of the first node will be null, and then the top will be given the value of the address of new node, which is 4600. So this is how it looks like. Now let's try to create a new node with a value of 48 and address of 4800. Now let's try to push this node into the stack. So this is how it looks like. Now the new node of data is given by the value 48 and new node of next is equals to top. So the pointer of the latest node will be assigned with the value of top, which is 4600, and then the top will be given the address of the latest node, which is 4800. So it will basically look like this, and let's try to create a new node again with a value of 22 and address of 5000. And let's try to apply the same algorithm again. Now the new node of data is value and the value given is 22 and new node next equals to top. Now the pointer of this node will store the value of top, which is 4800, and then the top it will be given the value of the address of the latest node, which is 5000, and it will basically look like this. So this is how push function works. Now let's see how pop function works. The algorithm of pop function says that if top is null, then it will return end of if statement, else temp is equals to top, top is equals to top next, and free temp and else and procedure. Now let's see how this works. Now if we want to pop an element here, temp is equals to top. So we will store the address of the latest node 5000 in temp. Then we will give top the value of top next, which is 4800 here. Now the value of new top will be 4800, and then it will point to the second node, which is like the previous node, and then we will free temp, in which we stored the address of the node which we just popped, that is 5000. So we are basically clearing the location of this one node in our memory so that we can store the memory. Now let's see how this will be looking when the top is pointing to the previous node, which is 4800. I hope you understood the pop function. Now let's see how isEmpty works. So the isEmpty function says that if top is null, then it will return end of if statement, else it will return false. So basically, if top is equals to null, then it will return true, or else it will return false. Here top is not equals to null, and top is basically the pointer which will be pointing. So here the top will be 4800, and peek function says that if top is null, then it will return end of if, else it will return the data in the top node, end of else, end of procedure. Here the top node as of now is the orange node, and the data which is stored in the top node is 48, so it will return 48. And this will be the visualization of what we just learned. Now let's see the last function, which is the display function, and the algorithm of display function says that if top is null, then return end of if statement, else while loop of top is not equal to 0, print top data, top is equals to top next, and else end procedure. So this says that here top is not equal to 0, so it will basically return or print the top data, which is 48, and then the top will be given the value of top of next. So in top of next we have the address of the first node, which is 4600. Now the top will be given the value of 4600, and the top pointer will be pointing to the previous node, which is the first node, and then the loop will return again, and it will print the data of top. Now the top is 4600, so it will print 11, and then top is equals to top of next. Now the top of next is null, so it will be 0, and here the while loop's condition is not satisfied, so the loop will end and the statement will end, and end of procedure. So these are all the basic operations of stack using linked list. Now let's see the last topic of this video, which is the applications of stack. So evaluating expression with operators and operands, conversions of expressions from one arithmetic notation to another, string reversal, function calls, backtracking, and parenthesis matching are some of the applications of stack. Now, some real life examples of stack is back and forward stacks on browsers in order to access the previous search we did and to go back to the same slide. And these are all the applications of stack and the basic operations of stack using array and linked list. So thank you for watching this video. Hope you have a great day.